Hey, welcome back. We are now in section 5.3, and we are going to be working on logarithms. Learning the properties of logarithms can be tricky, so hang with me on this. Now, let's just start off with what is the graph of log base 6 of x. Now, just right off the bat, we need to know the change of base formula for logarithms in order to work this one on the calculator. Because there is no log base 6 on our calculator. Well, there is, but you have to hunt around for it. And so, so y equals log base 6 of x. You can rewrite this as the log base 10 of x divided by the log base 10 of 6. Now, log with no base is technically log base 10, and it's called the common logarithm, and it is on our calculator. So let me show you what we're going to do on this one. So if you hit y equals, that log right there, you see how it has a 10x above it? This is the base 10, log. Alright, now logarithms are exponents. I know this kind of sounds backwards, but logarithms are exponents. They are the exponent that does certain things. So we'll hammer that home here in a minute. But right now, we're just going to do log of x. Now that would be log base 10 of x, but we want log base 6 of x. So we got to divide by the log of 6. And looks like we're on a window that's -5 to 5. So we'll do that. And log base 6 and log base 10 are actually, they look very similar. And there we go. Now it has a vertical asymptote. Let me copy that over here. Yeah, logarithms have vertical asymptotes. They are the inverses of the exponentials. Wrong place. They are the inverse of the exponentials. Let me undo that. The inverse of the exponentials had those horizontal asymptotes, and so the logarithms are going to have the vertical asymptote because it's a reflection of that piece. So so there's that vertical asymptote running down the axis over here, and then it's headed off slowly that way. So man, our choices are limited. It's got to be A. All right. It says make a hand-drawn graph of log x and check using your calculator. Just to get you some practice with logarithms, what we even mean by it. This is x, this is log x. Now, when we put in a value, let me do an obvious one like 10. The log base 10 of 10 means what is the exponent? This is what this means, is what is the exponent on the base 10 that gives you back 10. Kind of algebraically, it'd be 10 to what power is equal to 10, and the answer is y equals 1. So this would be a 1. Alright, so it undoes, it does the so it tells you the exponent. The logarithm itself is the exponent on the base that makes that happen. Let's do another one. Let's do a 1. So this means 10 to what power is 1? And the answer is y is equal to 0. So 0 is the exponent on the base 10 that gives you back a 1. Alright. And so you can see which graphs that we're talking about here. At 0, we're supposed to be at 1. At 10, where are we? That's not it. At 0 is supposed to be, sorry, not at 0. At 1, we're supposed to be at 0, which is that one. And at 10, we're supposed to be at 1. So it's kind of hard to see it going down that way, but that is the right one right here, B, not that one over there. Check using your graphing calculator. Again, we have the log base 10 on the calculator, so we just delete that, hit graph, and you can see it over there. It's got to be B. All right. Now they said do a standard window, and so this will match it a little bit better. Definitely this one over here. A. All right, I'm going to end the video right there, and then we're going to do some properties of logarithms in the next video. Thanks.